Hello dear students, this is Dr. Pramod P. Professor ECE Department LBS College of Engineering Kasaragod. Today we will discuss an important topic, that is modeling concurrent functionality in verilog. So in that we will be discussing continuous assignment with logic operators, continuous assignment with conditional operators, and finally continuous assignment with the delay. In Verilog, continuous assignment is a method to model combinational logic by directly assigning a value to a net, that is a wire, based on the valuation of an expression. For example, if our expression is like assign y is equal to a and b, a ampersand b semicolon, if that's the instruction, then actually the net, that is y, is every time updated when a or b changes. When a or the value of a or b changes, or both changes, at that time the net y is getting updated. It is a one-to-one mapping between the expression on RHS, that is right hand side, and the net on the LHS, that is left hand side. Whenever the RHS expression changes, as already illustrated or explained, the net is continuously updated, and the keyword used over here is assign. Here is an example for a continuous assignment module. It is named as continuous underscore ex1. Then its module declaration or definition or entity declaration is shown over here. Input via w and x, w comma x, then output wire is y. Now it's about description of the program. That is assign y is equal to w and x, w ampersand x, then semicolon, and this is actually continuous assignment explicit. This means that y is already declared as via in the for declaration section. Now we are assigning w and x to y, so that is continuous assignment explicit. And now in this case, when it is getting executed, y is continuously driven by the and of w and x. So every time w or x changes or both changes, y is getting updated. This particular section details how assign statement is used. The first example is assign f1 equal to a. So means that f1 is updated anytime a changes, where a is a signal. And the next one, similar to that, assign f2 equal to one single quote b0. This means that if it is assigned a value equal to binary 0. Then then comes assigning of a value to f3. Assign f3 equal to 4 single quote h double a. This means that it's a hexadecimal value, so that is assigned to f3. So each individual assignments over here, that is for f1, f2 and f3, will be executed concurrently and synthesized as separate logic circuits. Another example given over here, here x is assigned a value a, b is assigned to y, and c is assigned to z. And when simulated, these three lines of verilog will create three separate signal assignments at the exact same time. So that is, these are executed concurrently. It is basically different from programming languages, where in programming languages at first a is assigned to x, and then b to y, and finally c to z. Continuous assignment with the logic operators is illustrated over here. So an example here, the example is module logic circuit, that is logic CKT, and here the declaration, port declaration is done with the input wires a, b and c. Then the output wire is y. The required code for verilog code is assign y is equal to within bracket a ampersand b, that is a and b, then or within bracket c, inverted c. So that symbol you will be able to find. So in short, logical operators are used over here along with the continuous assignment. So whenever any of these values changes, or a combination of two changes, or together three values changes, in any case y will be getting updated. Now let's discuss another problem related with this. That is implement the following truth table using continuous assignment with logic operators. So in that you will be able to find we have three inputs A, B and C, and F is the output, and for these 8 combinations zeros and ones are shown at the output. So for the first combination it is 1 0 0 0, it is 1, and for the next combination 0 1 0, it is 1, and finally 1 1 0, it is 1. So the logic expression is like f is equal to a complement b complement c complement plus a complement b c complement plus a b c complement. So the digital logic diagram of the circuit for the expression written over here is shown. Let's proceed with the verilog code. The module, the name given is system 6. Then we have output f. So output via f, it is declared as via, and then we have input via a, b and c. So input via a comma b comma c. The ports are declared now. Now we will declare individual wires and assign values to them. So to the wires declared over here in this part is AN, BN and CN. So that is for actually generating the complement of A, B and C respectively. Then we have 3 more wires over there, M0, M2 and M6. So that is these are for internal nets. So this M0 actually corresponds to the AND of AN, BN and CN, and M2 is the AND of AN, B and CN. Then M6 is the AND of A, B and CN. So you will be able to find assign AN equal to assign BN equal to assign CN equal to. Then you will be again able to find, that is for NOT gates, creating NOT gates. Then assign M0, assign M2, M6, everything shown over there. That's for 3 input AND gates, 3 numbers of 3 input AND gates. Combining using an OR gate, we will be getting the final results. That is, we are going to assign F, that is assign F equal to M or M0 or M2 or M6. So that's it. Next topic is continuous assignment using conditional operators. Here the assignment is done based on the result of a specified condition. The primary conditional operators used in continuous assignments is ternary operator. So something like question mark you will be able to find over there, followed by a colon. Then the format usually is assign output net, then equal to condition, then ternary operator, then based on the condition, if it's true, the first value, that is value if true, then colon value if false. So if it is true, the first value will be taken, the condition. If the condition is false, upon evaluation if it is found as false, then the second value will be taken. Here is a very simple example for a multiplexer. Multiplexer 2 is one multiplexer, and wires, input wires are A and B over there. They are declared in the port declaration, and input wire again select line. Based on the value of select input, one among the two, A or B, will be selected at the output. So the output is declared as wire out. Then coming to the program description, it is assign out equal to cell. Then this ternary operator means cell, its output will be getting value based on the evaluation. So if a cell is 1, then it will be B, and if cell is 0, it will be A. So that's all about this particular problem. Now another problem, let's see now how to write Verilog code for this. And here a truth table is given, and ABC are the inputs and F is the output. As usual, porter declaration is done, and its name is given, module name is given, and we have declared the ports as output via F, then input via A, B, C. Then comes the assignment section, that is F is assigned directly all the combination values over there. Conditionally it is given. So like I will just read it out how it is coming. I will just explain to you. In this particular code, that is assign f is equal to, then written over there is for checking all the combinations over there. The first combination is a equal to 0, b equal to 0, c equal to 0. So if the AND product of this is 1, then the first will be selected, that is 1 single colon b1, that is selected, means the value is 1, otherwise it's 0. Now we will be checking and going for the next one, that is a is equal to 0, b equal to 0, and c equal to 1, and it is 0 over there, and the original f value is as per this program. It is written over there as 1 single colon v0, means v0 will be the output value. Then for the third combination, that is 0 1 0, it will be like the output is shown over there as towards the end, that third row end, you will be able to find one single quad b1, means 1 will be the result. So upon the execution, if it is correct, then it will be bit 1, that is output will be at logic 1. So that's it, and you can go through all these rows, and finally this particular program is a little bit bigger, and because it is actually checking all the combinations, no need for checking all the combinations. The previous program is actually reduced to a more compact form over here, and here actually what's done is for the three mentioned combinations for which output f is equal to 1, they only have taken over this for writing the code, such that, just for an example, the first code was a equal to 0, b equal to 0, and c is equal to 0, and that will be for that the output, if it is true, the selected output will be 1, and for the remaining two combinations also it will be like that, and for all the remaining combinations it will be one single quotes b0, means it will be 0 bit 0 at the output, f is equal to 0. So that's all about this particular program. It's a reduced one compared to the previous. This is another example where we are going to have continuous assignment with conditional operators. From the truth table, it can be found that for combinations 0 0 0, 0 1 0, then 1 1 0, for all these three combinations, the output f is equal to 1. The reduced output expression after reduction is f is equal to c complement into a complement plus b. The verilog code for the design module system X, so that's a name given, you can choose any name. Then within bracket you have the port declarations, output via f, then input via a comma b comma c. So with this the port declaration is over, then assignment is done directly with the conditional operator. So it is assignment, then we are going to check whether this c complement within bracket a complement plus b, if that value is 1, then the output will be 1, otherwise it is 0. So that is the ternary operator is used in this particular equation. You will be able to find it over there, and upon execution, if it is correct, then it will be 1, otherwise it's 0. So now we will discuss about continuous assignment with a delay. Here hash is used to indicate a delayed assignment. For combinational logic circuits, the delay can be specified for all transitions, number 1. Number 2, for rising and falling transitions separately, and number 3, rising transitions, falling transitions, and other transitions to the value. This shows an example of modeling of a delay, a single delay in a continuous assignment, and the single delay over here is shown over there as assign, then hash 1, f is equal to a and b. So what it basically indicates is that when a and b changes, definitely output changes accordingly. So you will be able to find initially the value of f is 0, then that is 0 into 0, it is 0, then it is 0 into 1, again it is 0, then it is 1 into 0, again it is 0 output, and again then For the next change, it is again A and B are 1. At that time, the output will be 1 because it's AND operation. So, but it will be getting updated during the leading edge of the output pulse. That is, output pulse means F waveform of F, and it will be updated after 1ns. That 1ns you will be able to find it over there. And during the trailing edge of the output waveform, so the output changes to 0, you will be able to find when A equal to 0 and B is equal to 0, output will be 0, but it will be updated only after 1ns. In the last example, we discussed about delay for all transitions, both for leading and trailing edges. And here, the leading edge and the trailing edge, we are specifying different timings. That is, you will be able to find assign hash 2 and 3, hash 2 comma 3. So that specifies that when it is getting updated and the output changes to high value, and at that time the delay will be 2ns. And if the output changes and the output is about to change it to 0, it takes 3ns to get updated at the output. Here is another example for a delay. You will be able to find over the assign hash 3, that indicates that when it changes, output changes, then 3ns takes to get it updated. But again, we will be able to find over there one pulse over there that change. So that pulse at the input is 1ns approximately, so which is less than 3ns, so it won't be considered, it will be ignored. So that's the basic concept behind this. Hope all of you may have very well understood the concept behind verilog coding. Thank you for watching this video. Have a very nice day. Meet you again.